Hello, everyone. All right, so for 9D, we're going to be talking about simplifying radicals and rationalizing the denominator. All right, so just to kind of introduce some vocab. So when I say a radical, we're really just looking at the square root symbol. So over here for a radical, it's literally just taking the square root. All right, so that's what we're going to be focusing on. So then we have what we call perfect square numbers. So perfect square numbers are pretty much saying when I take the square root of a number, it's going to give you a whole number and not a decimal. So for example, if I give you the square root of 16, well, that's going to be 4. Whereas if I take the square root of 24, that's not going to be a whole number. So 24 is not a perfect square. So just to kind of start off, we're going to start with these perfect square values, and we want to take the square roots of each of these. All right, so if I take the square root of 1, you actually get 1. So here's the thing. I'm actually going to come over here to the side. 1 times 1 gives you 1. But also keep in mind, -1 times -1 also gives you 1. So to account for both the positive and the negative value, since we technically have two solutions here, we actually kind of rewrite it as one solution. So over here, instead of just writing 1, we actually write a symbol called plus and minus, and then we write the number. So the plus and minus sign just accounts for both the positive and the negative value. All right, so for the next one, if I have a perfect square of 4, if I take the square root of 4, we're going to get positive and negative 2. So if I keep the pattern going, square root of 9, we get plus or minus 3, square root of 16, plus or minus 4, square root of 25, you get plus or minus 5, square root of 36, plus or minus 6, square root of 49, which is plus or minus 7. That's a terrible 7. Still a terrible 7. There we go. All right, square root of 64, which gives you plus or minus 8. Square root of 81, which gives you plus or minus 9. Then square root of 100, which gives you plus or minus 10. Then square root of 121, which gives you plus or minus 11. And square root of 144, which gives you plus or minus 12. So these are all the perfect square values that hopefully you just kind of have memorized by now. If not, I would definitely make sure you're good with these because it will save you a lot of time in the long run. All right, so now we're just going to go ahead and simplify some more radicals. So if I take the square root of 36, just as mentioned above, it's the same as plus or minus 6. But over here, if I take the square root of 196, you could either keep multiplying values and see if you get 196 eventually, like just kind of keeping the pattern going, like 13 times 13, 14 times 14, 15 times 15, so on and so on. And you can see if you eventually get one of these numbers. So if I actually keep the pattern going, 13 squared is 169, and then 14 squared is 196. So this is plus or minus 14. And then if I keep the pattern going, square root of 225 is actually the square, nope, it's plus or minus 15. All right, so I would actually encourage you to kind of memorize up to, I would say up to 20 would be a good idea. But of course, not required, but I would say having those perfect square values memorized up to 20 would be a very great idea. Or a very good idea. English is hard. I don't teach English. All right, so here's the thing. Not all these values are going to be perfect squares. So kind of thinking back to what I said before, what if you want to find the square root of 24? Oh my gosh, everything's fine. My iPad's freaking out. All right, so if I want to take the square root of, say, 24, we have to get a little more creative with what we do. So what I'm going to do is a factor tree. I want to find all the factors of that specific value. And when I'm doing the factor tree, I want to look for sets of 2. So I'm looking for pairs. So what I'm going to do is I want to write the pair numbers on the outside of the radical, and then inside the radical is going to be any values that are left over that did not pair off. All right. So over here, we're going to start with the square root of 48. So I want to find the factors of 48. So I'm going to do this using a factor tree. All right. So here's the thing. If your number ends with an even digit, that means it has to be divisible by 2. So when in doubt, kind of look at 2 and see. All right. So now I'm going to divide by 2, which is going to give me 24. 24 is even, so I'm going to divide by 2 again, and I get 12. 12 is even, so I'm going to divide by 2, and you get 6. And then 6 can break down into 2 and 3. All right, so what I'm looking for are pairs. So I'm going to actually highlight the pairs. So I have a pair of 2s here, and I also have a pair of 2s here. All right, now the only number that did not pair off is going to be this 3 right here. That was the only number that didn't pair off. So you're probably wondering, well, what the heck? What about like 24, 12, 6, and that 48? Well, once that number branches into some other values, we no longer even consider those values. So those are done. Once they split, they're done. We don't need it. We're only looking at the tail ends of those branches. All right, so what I'm looking for are the pairs which you only write one time on the outside. And then we have this 3 over here, which is our leftover. And these are going to be written on the inside. So when I say inside and outside, I'm talking about the radical. All right, so I'm going to kind of draw my radical. So this is outside the radical, and then I want values inside the radical. All right, so I have a pair of 2s right here. So I'm going to write that 2 only one time. And then I have another 2 over here. So I'm going to write that on the outside as well. You only write the pair number one time on the outside. All right, and then that leftover number, I have that 3 over there, which is going to go inside the radical. And then once you get to this point, then you would just want to simplify what you have here. So you want to multiply all the numbers that are outside together, and you want to multiply all the numbers inside together. All right, so when I simplify, we're going to have 4 root 3. So this is going to be our simplified, our simplest radical form. So what we're doing is we want to write each of these radicals in simplest radical form. All right, so what I'm going to do is I'm going to actually go ahead and pull this up on the Casio calculator. And I'm going to show you guys how to do these on here. So one thing to note while I'm pulling up the calculator, even though I can show you guys how to do these on the Casio, you can check it using the calculator, but on the assessments, practices, etc., whatever, you're still going to be required to show your work to receive full credit. Just keep that in mind. All right, so on the Casio, so I'm going to go to run matrix, delete this garbage. All right, so if I want to open a square root, the square root is actually this yellow symbol right here above the x squared. So because it's yellow, in order to get the square root, you have to press shift. So once I press shift, a yellow S will occur right here at the top left, right by the battery. And then you can press x squared and it will open up the radical. All right, so if I type in 48 and press execute, it will actually yield the simplest radical form. So you'll have 4 root 3. So technically, probably shooting myself in the foot here, the Casios will actually do all these problems for you. Now, if you have a TI, it'll give you a decimal value. So what you can do is if you get the decimal value, so let's do that. It'll give you this in the TI. So then what you can do to check it, you can do 4, shift, radical 3, execute, and then turn that into a decimal. And if they match, then you're good to go and they're correct. So this is a good way to kind of check. All right. So once again, I'm going to reiterate. You can use the calculators to help you on these problems, but you cannot rely on them to actually solve all of them for you. You have to show your work on the actual practices and assessments. Okie dokie. Back to notability. All right, so now I want to do the square root of 54. All right, so the square root of 54, so I can divide that by, so we'll say 2. All right, so when I divide that by 2, it's going to give me 27. And then 27 is divisible by 3 and 9. And 9 breaks down into 3 and 3. Now, one thing to keep in mind, the square root of 54, or the factors of 54, I use 2 and 27, but you could easily use, say, 9 and 6, or whatever other values that you can find. Your factor tree may look different than mine, and that's fine, because the factors you get at the very end of your factor tree should still be the same. They're just probably going to be in different places, which is okay. All right, so remember, once you branch that value is no longer considered. So now we're going to look for pairs. So I strongly recommend using highlighters or different colors or whatever. So I'm going to highlight my pairs. So I have a pair of 3s here. And I'm going to underline my leftover values to make sure I account for all of them. Because I will say, whenever your factor trees, like whenever you're finding the factor tree of, say, bigger numbers, like anything above 100, some of those factor trees can get pretty long, and it's really easy to miss a value. Like a little leftover value can easily get lost in the shuffle of all the branches. All right, so I'm going to go ahead and write my value. So on the outside, I'm just going to write the 3 once. And then on the inside, I have a 2, and I have that 3. All right, so when I simplify, I'm going to have 3 root 6. Perfect. It's exactly what I wanted. Is that a triangle or an arrow? It's an arrow. Close enough. All right, so now I want to do the square root of 72. So keep in mind, I'm going to do this one a little bit differently. So your pair numbers can actually be prime or composite numbers. So what I mean by that is, on purpose, I'm going to use 6 and 12. So when I split 12, I'm going to get 6 and 2. Now, if you look here, we have a pair of 6s. So I can actually use those as my pair and actually drag those out. So then my only leftover value here is a 2. So what I have here is 6 root 2. That would be my final answer. All right, I'm going to go ahead and do this one. If I fully break it down, just to kind of give you the idea that it doesn't matter. So if I do the square root of 72, all right, so if I'm going to do the same breakdown, so if I break down 6 into 2 and 3, then break down 12 into 2 and 6, then 2 and 3. All right, so I'm going to have to be a little strategic with my pairs here. So 2 and 2 here. And then I have a pair of 3s here. And then I have a leftover 2 right here. All right, so remember, any number that branched, I don't need it. So all those other values will have to be accounted for. All right, so on the outside, I would have 2 times 3, and the 2 on the inside, which is still going to give you 6 root 2. So even if you don't want to use the composite values, you can still break it down all the way, and you should still be able to get the same exact answer. It doesn't matter. But I would recommend using composite values if you can. It will make the problem a lot shorter, and it will make your life a little bit easier. All right, So I would actually say pause here and try these 3 on your own. All right, so for the square root of 75, remember, it doesn't matter which factors you use as long as you're breaking it down. Breaking the number down, not you having a breakdown. That's fine. All right, so that's a 3. To break down 75, I'm going to use 3 and 25. And then 25 breaks down into 5 and 5. So 5 and 5, that's my pair. And then I have a leftover 3 here. So we're going to have 5 root 3. So just remember, your pair numbers go on the outside, and then your leftovers stay on the inside. As a amazing teacher once said to me, if they're inside the radical and you find a pair, let me write it out this way. If they're inside the house and there's a pair, they're getting married and they're leaving the little church. So you want to look for pairs. All right. So this 3 right here tragically did not find a pair, so it's going to stay in the house. All right. So they're only going to leave the radical if there's a pair. And once you've paired off, you write it once and they're gone. All right. All right. So over here, square root of 120. So same idea. So I'm going to use 12 and 10. All right, and then 12 breaks down to 6 and 2. 10 breaks down to 2 and 5. So if you notice, I was a little strategic with how I kind of organized my factors. I organized it so that my 2's right here, I can easily just highlight those together as a pair. If you want to do your 2 on the other side and just kind of do your fancy highlighting or curve highlighting or whatever, go for it. All right, and then the 6 breaks down into 2 and 3. All right, so if it helps, you can get rid of any values that branched out. So the 120 is gone, 10 is gone, 12 is gone, and 6 is gone. All right. So we have leftover values of 5, 3, and 2. So those numbers did not pair off. All right, so I'm going to write the pair 2 on the outside once. Then everything else is inside the radical. And I'm going to multiply all those together. So 2 times 3, which gives you 6, and then 6 times 5, which gives you 30. So 2 root 30 is your final answer. All right, and number 15, some of you may have gotten a little stumped on this one. That's okay. It's to be expected. So when you break down 15, you can, oh my gosh, I cannot draw a 3. It's only going to be 3 and 5. There's no pairs. Nothing else can be rewritten. So because there are no pairs, what that means is it's already, my handwriting is so terrible. I am so sorry. Already in simplest form. So kind of another way of putting this is, let's say I give you a fraction of 1/2. It's like trying to simplify a 1/2 anymore. You can't. There's nothing else you can do. So it's just already in simplest form. All right, moving on. So now we're going to do what we call radical operations. So this is if we are multiplying, dividing, or potentially adding or subtracting. But we're really going to focus on just multiplying and dividing. All right, so what we're going to do here is I have 5 root 8. So here, I'm actually going to break down this square root of 8 first, and I'm going to worry about this 5 at the very end. So I'm going to just kind of ignore it. All right, so 8 is going to break down to 2 and 4. And that breaks down to 2 and 2. So I have a pair of 2's. And then I have a leftover 2. So this is the same as writing 2 root 2. All right, now keep in mind, that's only the 8. So what I'm going to do is I'm going to rewrite it as 5 parentheses 2 root 2. So I just simplified the square root of 8. So now what I'm going to do is I want to multiply the two numbers that are on the outside of the radical. Those I can multiply together. So here, 5 times 2 is going to give you 10. And I'm going to leave that square root of 2 alone. So we're just going to have 10 root 2 here. Okay. All right, now over here, for the next one, we have 2 root 8 times 3 root 6. It's the same idea. So what I'm going to do is reorganize it, and I want to group my outside values together, and then I want to multiply the inside values together. So 8 and 6 are going to be grouped together. All right, so I'm going to reorganize it and do 2 times 3 on the outside, and then on the inside, I have 8 times 6. All right, now on the outside, 2 times 3 just gives me 6. And then over here, I have 8 times 6, which is going to give you 48. All right, so I want to do the same thing that I just did in the previous problem. So I'm going to break down 48. All right, so 48, you can use 4 and 12, and then 4 and 3, and I have a pair of 4s here. So this is going to be 4 root 3. All right, so over here, I'm going to replace the square root of 48. There's a spider on my desk. There was a spider on my desk. It is dead now. All right, so I'm going to replace the square root of 48 with 4 root 3. And then do the same thing as before. I'm going to multiply the two numbers on the outside of the radical. So 6 times 4 is going to give you 24. And then leave the square root of 3 on the outside. All right, so once again, you can actually do these in the calculator just to check your work. So let me go ahead and show you real quick. All right, so if I do 2 square root of 8, so you want to make sure your cursor's on the outside of the radical, and then multiply. Then 3 shift x squared, 6, and then press enter, and you get 24 root 3, which is what we just got. Okay, so any of the radical operations you can plug in, simplifying the radicals you can plug in the calculator. The calculator literally, bittersweet, it does everything for you. It's great that it does everything for you, but also don't get in the habit, because your radicals are super, 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 super important for literally the rest of your STEM classes, for geometry, algebra 2, pre-calc, calculus, physics, even chemistry. Like, you need radicals for every math class that you're going to potentially take. So please learn these. All right. So over here, now we have square root of 14 times the square root of 7. All right, so since they're both inside the radical, I'm actually going to solve this one a little bit differently. So this is another way you could solve these. It's not required, but this is one of those problems that this is a perfect example of an alternative way to do it. So I'm going to do 14 times 7 inside the radical. But then what I'm going to do is I'm going to break down that 14 into 2 times 7. So right here, this 14 breaks down into 2 and 7. All right, and then inside the radical here, we have a pair of 7s. So it works the same way. So I'm going to take that pair of 7s and I'm going to write it outside the radical. So I'm going to have 7, and then inside I still have that 2. So there's your final answer. So if you actually prefer to do this way over here, where you're just specifically just working inside the radical, you can. Or if you want to do the factor trees because it's a little bit more visually friendly, you can. It's really up to you on how you want to do it. I personally just prefer the factor trees. It's very visual. I'm a very big visual learner, so it's just what I would prefer. But if you like this method over here, you're more than welcome to do it. It's the same thing. All right, so now we're going to move on to division. All right, so we have 7 root 14 all over the square root of 2. So what I'm going to do here is I'm actually going to combine the radicals into 1. So we have 7 times the square root of 14 over 2. And if you simplify 14 over 2, you get 7. And that's it. All right. Now, if that number inside the radical could be broken down more and simplified more, then you would keep going. But because 7 is prime, it can't break down anymore. You just leave it. All righty. So now over here, same idea. We have the square root of 72 over 6. If you simplify that, 72 divided by 6 is going to give you square root of 12. And then that's what we are going to break down. So 12 breaks down to 4 and 3. And 4 breaks into 2 and 2. We have a pair of 2s, which is literally just 2 root 3. All right. So now for the next one, we have the square root of 5 over 100. So look for those perfect squares. 100 is a perfect square. So what I'm going to do is I actually want to separate these radicals. Now, if I take the square root of 5, it's going to be a gross decimal. So I'm going to leave it as the square root of 5. But if you take the square root of 100, you get 10. And that's all you'd have to do. All right, so this is a good transition problem. Keep in mind, notice how the radical is in the numerator. If the radical is in the numerator, that is fine. However, if you have something like 10 over the square root of 5, the radical is in the denominator, and that is a big mathematical no-no. All right, that's mathematicians will flip over in their grave. I don't know why, they just will. So if something like that ever happens, then we have to do something called rationalizing the denominator. So when I say rationalizing, it's really just rewriting it. All right, so there's these 3 conditions that have to be met for these radical problems. So you cannot have any perfect square factors in the radical. So you can't leave like the square root of 100. You can't just leave it as the square root of 100. You have to rewrite it as 10. You cannot have any fractions in a radical because technically that radical would be in the denominator, which is a no-no. And you can't have any radicals in the denominator in the first place. All right. So really this last one, this is the big one. All right. So when I say we're going to rationalize, we're going to rationalize the denominator by a form of 1. Now, when I say form of 1, if I multiply something times 1, so let's say I'm doing 5 times 1. If I do 5 times 1, that's just 5. It doesn't change the value. But if I change the form of that 1, say 2 over 2, well, that still simplifies to 1, so 5 times 1 is still 5. But I'm just changing the way that 1 looks. All right, so what I'm going to do is I want to rationalize based on the number that's in the denominator. All right, so what I'm going to do is I want to multiply this by 1, but I need to change the way that 1 looks. All right, so the reason I'm multiplying by a form of 1 is I don't want to change what the actual value is. I just want to change its form. So it's kind of like when you freeze water, it turns into ice. However, the chemical compound is still H2O. When you boil water, it turns into steam or water vapor. It evaporates. It's still H2O. It's just a different state of matter. So it's kind of like what we're doing here. We're just changing its state of matter, kind of, but the math equivalent. All right, so in order to do that, I'm going to multiply by a form of 1. But I want to do that using the value that's in the denominator. So I need to get rid of the square root of 3. So to do that, I'm going to multiply by the square root of 3 over the square root of 3. So if I simplify this, it's still 1 if I simplify it. So I'm not actually changing the value. All right. So when I multiply across, so in the numerator, I'm going to multiply 2 times the square root of 3. So I'm going to have 2 root 3. And then in the denominator, we're going to have the square root of 3 times 3, which then I'm going to rewrite as 2 root 3 over the square root of 9. And then the square root of 9, that's a perfect square. So we have 2 root 3 over 3. So now there's no radicals in the denominator. There's no fractions inside of a radical. And there's no perfect square values that can be simplified. So this right here is my simplest radical form after rationalizing. All right, so if you notice, here's the big thing right here to notice. We multiplied the square root of 3 times the square root of 3 and ended with 3. So here's a little pattern I want you to notice. Let's say I multiply the square root of 4 times the square root of 4. Well, here, that's going to give you square root of 4 times 4, which is going to be equal to the square root of 16, which is 4. All right, so same idea if I do, say, the square root of 5 times the square root of 5. So this is the key part for rationalizing. So this is going to be the square root of 5 times 5, which is going to be the square root of 25, which is 5. So notice how we're starting with 2 of the same and ending with that value. Starting with 2 of the same, ending with that value. So I'm going to let you take a gander at what the square root of 6 times the square root of 6 is. Well, spoiler alert, it's 6. So same idea if I do it with the square root of 7 times the square root of 7. Well, you get 7. It's just that number. So the reason that is because of the law of exponents. Because if you remember, anything that has a square root is raised to a 1/2 power. Okay, so I'm going to go through this kind of quick just to show you kind of the reason why this works. All right, so I'm going to use the 4s as an example. So the square root of 4 times the square root of 4. This is equal to 4 to the 1/2 power times 4 to the 1/2 power. And then if I use product rule says if I have the same base, I can add those exponents. So that's 4 to the 1/2 plus 1/2, which is 4 to the first power, which is just equal to 4. Okay, so there's like an unofficial little proof, I guess. All right, so that being said, now I'm going to move on to the next one. So we're always going to rationalize by whatever values in the denominator. All right, we don't care if the radicals are in the numerator. The radicals just cannot be in the denominator. All right, so I'm going to rationalize by the value that's in the denominator. So the square root of 15. So that's going to tell me to multiply by the square root of 15 over the square root of 15. All right, so I'm going to multiply across. So square root of 5 times the square root of 15. And then in the bottom, square root of 15 times the square root of 15, well, you get 15. All right, so here, I'm actually going to I'm going to split 15 into 3 and 5. So 5 times 3, all over 15. And then here, I have a pair of 5s. So that pair of 5s is going to come outside. All right, so what I'm going to have is 5 square root of 3 over 15. All right, so now that we simplified it and put it in simplest radical form, now we want to see if we can simplify the fractions. So unfortunately, we're not done. So if you look here, 5 over 15, that can simplify even more. So 5 over 15 is going to simplify to 1/3. So we're going to have 1 square root of 3 all over 3. All right, so there's that 1/3. Now, in the top, right here, we don't have to write that 1. So that 1 can really just disappear. So our final answer here is we're just going to have the square root of 3 over 3. So this is our final answer right here. Square root of 3 over 3. So once again, the calculators will also do these for you as well. Just make sure you're checking either the English is hard, decimal expansion, or if you're using a Casio, it will simplify these to simplest radical form using rationalization or rationalizing for you. All right, so down here, I'm only going to do a few of these. I'm not going to do all of these just because you have the calculator to help check. So for this very first one here, I'm going to rationalize by the denominator value. So the square root of 7 over the square root of 7. I'm going to multiply across. So we're going to have 5 root 7 over 7. The fraction cannot simplify anymore. So this is your final answer, 5 root 7 over 7. All right, so some of your rationalizing problems are going to be as simple and straightforward as this one, but they won't always be, tragically. Number 2. All right, so I'm going to multiply by the radical value in the denominator. So the square root of 2 over the square root of 2. Then multiply across. So 9 root 2 all over 2. Fraction cannot simplify. So this is our final answer right here. So some of these problems go by pretty quick. Some of them will not. So sorry, but also not sorry. All right, now number 3. So if you look here at this one, a lot of simplifying radicals is going to be about thinking, or no, well, yes, thinking, but working smarter, not harder. So if you see here, 27 is actually divisible by 3. So I'm actually going to combine that into one radical. So when I combine that into one radical, 27 divided by 3 is going to give you 9. Square root of 9 is just 3. So I didn't even have to rationalize on this one. You could rationalize by multiplying by the square root of 3 over the square root of 3, but it's going to give you the same answer and a whole lot more work. All right, so I highly recommend work smart, not hard. All right, number 4. All right, so remember, rationalize using the value in the denominator. So multiply by the square root of 2 over the square root of 2. So multiply across, so I'm going to have the square root of 2 over 2. Now keep in mind, the square root of 2 over 2, those are not the same value. The square root of 2 is like 1 point something. That is not the same as 2. So you cannot just cross out those 2's and write 1. You have to leave it as the square root of 2 over 2. All right. All right. 5. So before I even consider rationalizing, 75 and 50 are both kind of big numbers. So I'm actually going to simplify this fraction first. So when I simplify the fraction, we're going to get 3 over 2. All right. And then when I get to this part, then I'm going to split up that radical. So I'm going to write the square root of 3 over the square root of 2. And then from here, then I'm going to multiply and rationalize. All right, so when you multiply across, so you're going to have the square root of 3 times 2 over 2. And this is going to give you the square root of 6 all over 2. All right, so remember, none of these answers, none of them have a radical in the denominator, none of them have a fraction in the radical, none of them have perfect squares. So we're satisfying all these rules. All right, number 6. All right, so I'm actually going to start by simplifying the fraction first, because 5 and 25, they have a greatest common factor of 5. Actually, no, just kidding. Scratch that. 25 is a perfect square. So I'm actually going to separate. When you separate, the square root of 25 is just 5. So you're going to have the square root of 5 over 5. Done. So once again, you can rationalize, but you don't have to, just because of problems like this, or they can simplify. You know what? We'll go ahead and just do it whole. All right, so for this last, nope, number 6, nope, 7, everything's fine. I'm going to rationalize by the value in the denominator, so the square root of 6 over the square root of 6. All right, so I'm going to multiply across. So I'm going to have 7 root 7 times 6 all over 6. All right, and when you start simplifying, we're going to have 7 root 42 over 6. So this is going to be your final answer right here. So if you're thinking, wait, what about 42? Can't you break that down? Well, let's try. Let's see what happens. So if I break down 42, that's 2 and 21. 21 breaks down to 3 and 7. There's no pairs, so it's already in simplest radical form. So there's nothing we could do. So you just pretend that never happened. Okay. All right, and last but not least, we have 3 root 18 all over the square root of 4. All right, well, the square root of 4, that's just 2. So I have 3 root 18 all over the square root of 4, which is just 2. So what I need to do here is I need to break down the square root of 18. So that breaks down to 2 and 9, and 9 breaks down to 3 and 3, which has a pair of 3s. So this can be rewritten as 3 root 2. So I have that left over here. The 18 and the 9 we no longer even look at. So I'm going to replace the square root of 18 with 3 root 2. All right, so this is going to be equal to 3 parentheses 3 root 2 over 2. And then you're just going to multiply those numbers on the outside. So the 3 times 3, which is just going to give you 9 root 2 over 2. So this is your final answer and your simplest radical